Good afternoon, good evening, everyone. Now, today's lecture 7 on engineering concepts in early childhood education. So these are today's aims: to discuss the basic engineering principles and understand the importance of introducing basic engineering principles in early years, to know the best practice in designing engineering projects and reflect on examples and on practice. So in early years education, when we integrate basic engineering principles in STEAM framework, it helps children develop foundational skills and knowledge in the engineering concepts. Here are some basic engineering principles that are suitable for early years education. Simple machines introduce young learners to the concept of simple machines such as levers, pulleys, inclined planes, and wheels. Explore how these basic mechanisms make work easier and how they are used in everyday objects. Structure and stability. They provide opportunities for children to explore the principles of building structures and understanding stability. In terms of balance and counterbalance, it can teach children about the concept of it by engaging them in activities that involve stacking and balancing objects, encouraging them to experiment with different weights and positions to achieve the balance. Motion and forces. By introducing children the basic concepts of motion and forces, they can explore concepts such as push and pull, gravity, friction, and momentum using simple experiments and demonstrations. Problem solving and design thinking fosters problem solving skills and design thinking through presenting children with open-ended challenges and engineering projects. Encourage the students to identify problems, brainstorm ideas, create prototypes, and test solutions. Measurement and geometry. So this integrates measurement and geometry concepts into engineering activities by exploring concepts such as size, shape, length, and volume. It provides opportunities for children to use measuring tools and geometric shapes to design and build structures. In coding and robotics, you can introduce the basic concepts, coding and robotic concepts, through age-appropriate activities and tools, using coding toys or programmable robots to teach sequencing, patterns, algorithm, and problem-solving skills. I don't know if you've heard of B-bots, but back in the UK, we used to use a lot of B-bots in the early years to develop coding and sequencing. Now, creative and innovation. We can encourage children to think critically, take risks, and explore new ideas in their engineering projects. And we can provide opportunities for them to design and create their own inventions and solutions to real-world problems. So by integrating these basic engineering principles in early years education within the STEAM framework, you can lay the foundation for young children to develop essential skills such as critical thinking, problem solving, creativity, and collaboration, while also fostering a love for STEM fields for an early age. And this critical thinking, problem solving, creativity, and collaboration, these are all the 21st century skills that are very aligned with the STEAM. Now, why is it important to introduce the basic principles in early years? Now, it's important for several reasons. Early exposure to engineering concepts encourages young children to think critically and analytically as they explore how things work and why objects behave the way they do. And this lays the groundwork for problem-solving skills that are essential in engineering and other STEM fields. Engineering activities promote creativity and innovation by encouraging children to explore new ideas, experiment with different materials, and design their own solutions to problems. And this fosters a sense of curiosity and exploration that is fundamental to innovation and invention. Engineering activities also often involve concepts related to geometry, measurement, and spatial reasoning. And by engaging in hands-on building activities, children develop an understanding of shapes, sizes, and spatial relationships, laying the foundation of mathematical thinking, which was very clear when I was talking about the basic engineering principles. Engineering projects often require collaboration and communication as children work together to brainstorm ideas, solve problems, and test solutions. This fosters social skills such as teamwork, cooperation, and effective communication, which are important in all areas of life. It provides opportunity for children to learn from failure, iterate on their designs, and persevere in the face of challenges. And this helps them to develop resilience and a growth mindset, understanding that setbacks are a natural part of the learning process. Now, I've talked about growth mindset in one of my previous lectures back in December, January time. So hopefully you'll be able to access them in the International Association for Quality Education website and the YouTube channel. Now, introducing engineering principles in early years education helps prepare children for the future careers in STEM fields. So by building a strong foundation in engineering concepts and skills from an early age, children are better equipped to pursue further education and careers in fields such as engineering, technology, and design. So overall, introducing these basic engineering principles in early years education lays the foundation for children to develop essential skills and mindsets that are valuable not only in STEM fields, but also in all areas of learning and life. So by fostering curiosity, creativity, critical thinking, and collaboration, early engineering experiences set children on a path towards lifelong learning and success. While there may not be specific theorists who have developed a step-by-step guides for designing engineering projects for young children, there are education approaches and methodologies that inform the design of such projects. And some of these approaches include constructivism. Now, this theory, often associated with Jean Piaget and Lev Vygotsky, emphasizes on hands-on experiential learning. Now, in the context of engineering projects for young children, constructivist principles suggest that children learn best when they are actively engaged in exploring, building, and solving problems. In terms of project-based learning, also known as PBL, is an instructional approach where students work on long-term projects that involve solving real-world problems or answering complex questions. While there may not be specific theories associated with PBL, it's very much aligned with constructivist principles and emphasizes on student-centered, inquiry-based learning. Now, again, I've also, if you check the previous lectures that I did back in December and January on PBL and inquiry-based learning, You'll find more information about these ways of approaching learning. Now, STEM education integrates concepts from science, technology, engineering, and mathematics into interdisciplinary learning experiences. While STEM education doesn't have a single theorist, it draws on constructivist principles again, and emphasizes the integration of hands-on engineering activities to promote problem solving, critical thinking, and innovation. Now, lastly, Reggio Emilia approach, which is developed by Loris Malaguzzi. Its emphasis is on the importance of child-led, play-based learning experiences. While not specifically focused on engineering, this approach values children's natural curiosity, creativity, and exploration, which are important elements of designing engineering projects for young children. Now, when designing civil engineering projects for children, it's essential to consider their development stage, interests, and abilities. Projects should be open-ended to allow for exploration and creativity, and should incorporate hands-on activities that promote problem-solving and critical thinking. Additional to this, projects should be connected to real-world contexts and should provide opportunities for collaboration and reflection. While there may not be a single set of steps developed by a specific theories for design engineering projects for young children, you can draw on principles from constructivism, project-based learning, STEM education, and approaches like Reggio Emilia approach to inform your design process. And actually, when I was putting this lecture together, I did come across this lovely song, which I'm going to put for you to listen to, which is very much appropriate for young students. Now, this teacher uses the song to remind children of the engineering design process that she follows with them. Let's listen.
You ready? Yeah. Here we go. We are engineers. We are engineers. We are engineers. First we explore, then we create, improve to make it better, because engineers are. Nice job, engineers.
Now, so you could see it was very active and engaging. So it encouraged and promoted the children to be focused on the learning and to get them ready for the learning that's what's to come. So they follow the explore, create, and make it better kind of design process. Now, I would encourage you to search for engineering design process and see which one resonates with you and why. Sorry. Okay. Now, here is a video that I found on engineering with young children. And I thought it would be good for you to see how engineering was used with the Three Little Pigs story.
Young children are natural scientists, curious about the world around them and readily inclined to discover new things. While many of us think about STEM, science, technology, engineering, and math, as learning that begins in elementary school, the foundation for STEM thinking and STEM processes is nurtured and developed well before children enter kindergarten.
Maybe you can take some Play-Doh from the bottom. From the top.
When we think about introducing STEM in early childhood, it is not about setting aside an extra segment of time to address STEM topics, when the day is already packed full of activities. Instead, the goal is to integrate STEM processes into the daily routine and into one's early childhood curriculum.
Well, how do you say that, Emma?
The introduction of STEM thinking is about giving young children opportunities for active, hands-on exploration and experimentation, and building their critical thinking, prediction, and problem-solving skills. Educators need not be STEM experts to offer learning experiences that pique young children's curiosity and nurture their penchant for discovery.
Oh, sorry.
STEM process.
Sorry.
When we think about integrate STEM processes into the
Well, how do you say that, Emma?
I just wanted to say that they were mentioning design thinking. Again, it would be worthwhile checking my previous lectures that you'd be able to find in the International Association for Quality Education website, as well as their YouTube channel on design thinking.
The introduction of STEM thinking is about giving young children opportunities for active, hands-on exploration and experimentation, and building their critical thinking, prediction, and problem-solving skills. Educators need not be STEM experts to offer learning experiences that pique young children's curiosity and nurture their penchant for discovery.
Yeah. All right. You guys like? Yeah, that's a pretty fun book, right?
Early childhood educators can use books, going to the library and choosing a book to enhance their STEM activities. Nearly every children's book you pick up and you start reading through it, you'll find some inkling of a STEM experience that you could try with children.
Meanwhile, the third pig remarked, "It's very nice, but I think I'll think it's strong." So the third little pig searched everything. What can I find that will be better? Brick. Think that's a better idea?
Yeah,
You
he's
know
the
what?
smartest pig
He's the smartest pig.
because it's strong.
We read The Three Little Pigs today because it's a really good story about how the building process works and what makes a good house, what are good engineering ideas. So we read that for the kids so that they could kind of jump off of that and decide how they wanted to build their house with what materials. Little pigs, let me in. They shouted, what did they say? Then I'll huff and I'll blow your house. Alright? Does that work?
No.
No, let me try it. For today's activity, we've looked at different structures and how they were being built. We also talked about, the structures that the kids live in, what they're made out of: brick, wood, stone. And then we brought it all together in an activity where they can make their own houses and see what materials they would use. So we really did all of this to kind of bring it back to STEM and bring it back to engineering so that the kids could get, their own hands-on experience.
And you could see when she mentioned about that she got the children to think about their own houses where they live and the kind of material it's made of. So she brought it back to their own life experience to make it relevant for them.
What do you think a good house would be? Brick, what else do you think it is? Maybe sand?
The houses are all going to look different. Some of them are going to collapse, but that's a part of scientific method. Sometimes when something fails, it's not a bad. You want them to go back and try again and try again. And that's what we really want children to understand, is that if something doesn't work the first time, it's not a big deal. It means we're going to learn a lot more by going back.
So it's having that perseverance and that growth mindset to keep on going, not to give up, and keep on trying to make it better. And that's what STEM is all about. Engineering is all about. Explore, create, make it better and better and better.
Finding out what did not work and making some changes.
Juliana, how do you think we can make these stronger so we don't fall down? We love having the kids work in teams in our classroom just so that they can build those interpersonal skills and learn how to work together. And it really helps them when they get stuck. They don't know what they're doing or how to build a house. They can ask their friend for advice or they can see what their friend is doing and kind of build off on that.
What about we all build together? I don't know what's this, but I can't open up this. Look, I know though.
We just observe them and just watch and ask them open-ended questions, seeing what is their thinking process, because that's really what we want to see. We want to see the process, not the end product. So we want to see how they're thinking.
That is key. It's all about the process, the journey, not the outcome. And that's not just for engineering, it's in learning as a whole. It's about the progress, the journey that the children take towards that goal. That's important. And you can see that how the teacher, like her role is important in this scenario. She is being a facilitator. She's asking open-ended questions. She observes and see when she should intervene to share a comment or ask a question to support them with their design thinking or to further challenge them in their design and thought process. She's not necessarily giving them the answers. She's allowing them to come up with their own and giving them the space to try, make mistakes, work together, and support each other.
When doing an activity like the Three Little Pigs, when children have spent a lot of time building a house and they're excited to, look, and they want everybody to see what they've made, they may not want to do the next part, which I find extremely exciting, is to blow it down and see whether it stands. So if a child doesn't want it to be blown down, you leave it. Or you can take photographs of it to allow them to picture of their house, respect the children's wishes.
So the big bad wolf said, I'll hunt, and I'll hunt, and I'll blow your house down. Try to blow it down. Did it blow up?
So now I would like you to pause and reflect on today's lecture and share with someone at home what do you know now from watching this lecture. How do you feel about it and what might you use in the future? Once you're ready, you can move to the next. So as we end this lecture, I want you to think about how the engineering project in the video was successful. What made it successful? What did the adult do to support and challenge the students in their own learning? Now, this lecture marks the end of Module 2, which is on STEM Foundations in Early Childhood Education. I hope you join the live end of module reflection with Miss Usha. See you soon. Bye-bye.
Fly so high, I'm hypnotized. What's up is down, what's left is right. Chasing stars and holding you. I can't see the end, but we'll see it through.